So far this chapter, this unit, we've only talked about parallelograms, our quadrilaterals, four-sided figures that are just parallelograms. So that was 5.1 and 5.2. We focused on the properties and theorems that relate to parallelograms. Today we're going to learn about more specific types of parallelograms. So they will be the rectangle, the rhombus, and the square. So we will apply definitions, identify special properties of these three things, and we will determine when a parallelogram is a rectangle, a rhombus, or a square. So a rectangle, our first one here, well, if you look at the definition just says basically it's a quadrilateral with four right angles. Okay, quadrilateral, let's think about that for a second. That's just a very general term for a four-sided figure or four-sided polygon. Right? So why then do I know that it's a parallelogram? So that's my next question to you is how do we know it's a parallelogram if it just says simply four-sided figure? Well, let's draw the diagram really quickly. My guess is that if you sketch the diagram, you would make your rectangle look something like this. And probably naturally you wouldn't have put these right angle symbols in there. You just would have made a structure that had two sides longer than the other two sides. That's kind of the traditional rectangle of what we think of naturally. But specifically, in order to know something is a rectangle, we must have four right angles. So every corner here must contain a 90-degree angle. Okay, well, if I label this rectangle A, B, C, D, then what do I know? Well, I know that angle A is congruent to angle C, right? Those are congruent to each other because they're both 90 degrees. And then I know that angle B is congruent to angle D. Okay, again, they are both 90 degrees. Well, why am I choosing those pairs specifically? I'm choosing those pairs specifically because they are opposite each other. So in this quadrilateral, we have opposite angles that are congruent. And last section 5.2, we talked about if it is a parallelogram, then you know opposite angles are congruent and opposite sides are congruent. But then we also knew that if opposite angles are congruent, then it is a parallelogram. You could do the converse of that. So that was 5.6. So why is it a parallelogram? Because of theorem 5.6, which says if both pairs of opposite angles are congruent, then it must be a parallelogram. So both pairs of opposite angles are congruent, therefore it must be a parallelogram. So that's why we know, even though it just says quadrilateral here. So going back to that, well, what do we know then? It's not just a rectangle. We now know that these opposite sides are parallel to each other because that's the definition of parallelogram, and we just said it's a parallelogram. We also know that opposite sides are congruent to each other. Why? Because that's what a parallelogram is. We know that opposite angles are congruent to each other. We know what about their diagonals? We know according to 5.3 the diagonals of a parallelogram bisect each other, right? So if I made diagonals in here, we would know that they bisect each other. Okay, so those are all the different little details we know about parallelograms. And a rectangle is a parallelogram. Therefore, all those things from 5.1, 5.2, and 5.3, those theorems, hold true for a rectangle. The added part is that the four right angles in the corners. Okay, a rhombus. A rhombus is a specific type of parallelogram. It's a quadrilateral, again, that general term, a four-sided figure, with four congruent sides. If you were to sketch that, you might do something like this. And you would say that all four of these sides are congruent to each other. Okay, well, if all four sides are congruent to each other, why does that tell us that we have a parallelogram on our hands? Well, again, if I label this A, B, C, D, this time I can say segment AB is congruent to segment CD, and I can say segment BC is congruent to segment AD. Why am I doing those specific pairs? Because those are opposite each other. And theorem 5.4 says if
both pairs of sides opposite of each other, both pair of opposite sides are congruent, so instead of angles, it's both pairs of opposite sides are congruent, then we have a parallelogram. So that's why we know that a rhombus is also a parallelogram. Okay, so what do we know from there? Then you know that angle B is congruent to angle D, angle A is congruent to angle C. We know that their diagonals bisect each other, right? So there you go. We already said opposite sides are congruent to each other, and then we also know that opposite sides are parallel to each other. Okay, square is also a specific type of four-sided figure. So it's a quadrilateral with 4 right angles and 4 congruent sides. Okay, so therefore why is it a parallelogram? Where these two are parallelograms because opposite sides are congruent, opposite angles are congruent, then a square must also be a parallelogram because opposite angles are going to be congruent and opposite sides are going to be congruent. So your square has to have specifically 4 sides that are congruent to each other and 4 corners with 90-degree angles. So it must look something like this. Okay, now let's talk general umbrella here. Right? What do we know? We know that everything, all of these are parallelograms. So a parallelogram encompasses all 3 of these things. And then what's the next big part or little thing underneath, or we're talking about a Venn diagram? All rectangles are parallelograms, right? So they have their own bubble. But all squares are rectangles, right? Can't a square be a rectangle? Well, yes, because it has 4 right angles, so therefore it's a rectangle. Can a square be a rhombus? Well, yes, because it has 4 congruent sides, and that's what a rhombus is. So let's not talk about this little Venn diagram. We can talk about that more specifically in class. But instead, I want you to take a break. I want you to pause and go down here and just think about all that stuff I just talked about and answer true, false for these questions. And then when you've done that on your own, then come back and listen to my explanations. So go ahead and pause now, try it on your own, and then come back. Okay, one of the things I should have said before you paused was I should have said in order to make something false, you just have to come up with one counterexample. Remember that counterexample, that word. And so if you can come up with one counterexample, then you know the statement is false. So question number 1, are all rectangles parallelograms? Yes, they are. We just talked about that above. It's a quadrilateral with 4 congruent angles, therefore it must be a parallelogram because opposite angles are congruent to each other. But are all parallelograms rectangles? No, of course not, right? If I drew a rhombus, that's a parallelogram, or if I just drew a regular old parallelogram with no specific properties other than the parallelogram properties, that's definitely not a rectangle because I don't have 4 congruent angles. So there's my counterexample. So that's false. All rhombuses are parallelograms. Yes, they are. We talked about that above. Are all parallelograms rhombuses? No, of course not. A rectangle is not a rhombus, but it's a parallelogram. A square is a rhombus, actually, so that's not a good counterexample. The rectangle is your counterexample. Are all squares parallelograms? Yes, they are. Are all parallelograms squares? No, of course not, because rectangles are parallelograms and rhombuses are parallelograms, but those are not squares. Are all squares rectangles? So going by the definition up here, all squares must have 4 right angles. And all rectangles must have 4 right angles. And they're both quadrilateral. So are all squares rectangles? Yes, they are. Are all rectangles squares? No. A square is a specific type of rectangle. Right? Specific type of rectangle, because then it's narrowing in, or specific type of parallelogram. It's not only having congruent or 90-degree angles in the corners, but it's also having congruent side lengths. So all rectangles do not have congruent side lengths, therefore not all rectangles are not necessarily squares, so that's false. What's my counterexample? My counterexample is this. This is a rectangle, but it's not a square. right? And specifically, I should put these marks on it to show that these are bigger or different size than these over here. All rhombuses are squares. So are all rhombuses squares? No, that is false. What's my counterexample? Well, just the typical, maybe more typical rhombus that you see. It's skewed like this, where this is clearly an obtuse angle, an acute angle, an obtuse angle, and an acute angle. And then all squares are rhombuses. Well, yes, that's true, because all squares have 4 congruent sides, and all rhombuses have 4 congruent sides. So yes, a square is also a specific type of rhombus. And you know what, going back up here, we didn't review that. One of the things I forgot to review about parallelograms is that their consecutive angles are supplementary, right? So angle D and angle A are supplementary. They're 90 and 90, that's 180. A and B are supplementary, B and C are supplementary, C and D are supplementary. So that reminded me of that down here when I was looking at my rhombus. That means with my, here I'll draw another one. In a rhombus that's skewed like this, you have an obtuse angle and then you have an acute angle. Well, these two angles have to add up to 180 degrees. And these opposite angles are congruent, so these two angles have to add up to 180 degrees, right? And these two angles add up to 180 and these two angles add up to 180. So that's one of the properties of parallelograms I forgot to review above. Okay, so that's the overview of parallelograms, or sorry, specific parallelograms for rectangles, rhombuses, and squares. Here are some theorems. A rectangle diagonal theorem. So what do we know about parallelograms? The only thing we know about their diagonals is that they bisect each other. But a rectangle, more specifically, has diagonals that are congruent to each other. And don't forget, because all squares are rectangles, then squares' diagonals are also congruent to each other. So squares' diagonals are congruent to each other and they bisect each other. Rectangles' diagonals are congruent to each other and they bisect each other. So let's look at the rhombus. The rhombus diagonal theorem says that diagonals of a rhombus are perpendicular, right? So if we connect these diagonals to each other, they're going to intersect right here at 90 degrees. Well, not only that, we know from the parallelogram that they bisect each other. So they're perpendicular bisectors of one another. These diagonals of a rhombus are perpendicular bisectors. Well, again, remember that all squares are rhombuses, so my diagonals in a square are also going to perpendicularly bisect each other, and not to mention all 4 of those pieces in there are going to be congruent to each other as well. Finally, 5.14, which is the rhombus angle theorem. So it says each diagonal of a rhombus bisects the 2 angles of the rhombus. So right here, that means these 2 angles are now congruent to each other. It bisected it. It split it in half. These 2 angles up here are congruent to each other. And on this side, these 2 angles are congruent, and they must be congruent to the 2 opposite. So there you go. Okay, let's move on. There's a lot of little detailed information in this specific section, so you need to go back and review all those details. Read these theorems over and over again. Draw note cards, draw diagrams, try to help yourself out because you're going to have to solve a lot of stuff algebraically based on all that information. Okay, now you need to get your straight edge, your compass, and we're going to do a construction. And for some of you from different classes, this construction might be new to you. If you were in my class, I think a few others, maybe Mr. Murgatroyd's, you've already done this construction, so it'll be a review. So go ahead and go grab your your tools, and then we'll go to the next video to continue on. Talk to you soon.